Okay, this meeting is now being recorded. And so welcome. This is the work of the Evernym sponsors on the Hyperledger Indy project. We have two teams that sprint in tandem. One works on the SDK, it's the smaller team, and the larger team works on the node infrastructure. And this is the 11th sprint this year, 1811. This sprint, our goal was to complete this 1811 sprint, the SDK was focused on completing payments implementation and also improving the performance of the SDK. The Node team was also focused on stability and performance, and they have been working on a design of the view change algorithm. Improvements we're going to make to the view change algorithm, specific bug fixes we can do immediately. So that's what we've been working on. So I am going to let Sergey share his screen, and he's going to take us through the new support for state proofs for custom transactions. Then Nikita is going to take us through the improved get-validator-info command, and then we'll turn to the Node team, and we'll talk about ways that we're trying to improve the availability of the network, the robustness against attack, by isolating traffic to specific network interfaces. And then we'll talk about how we're using the request digest. So with that, I've stopped sharing. So Sergey Minaev.
Hi everyone, let me share my screen. I would like to announce new feature in libIndy, a new API. As you know, our network allows to reduce load for client node communication by using state proof. There is also...
Are you sharing your screen?
Yeah. Did you see it?
Yes, sorry. Yes. Mine was hidden. So I think everybody else saw it the whole time. Go ahead.
Okay. As you may know, there is state proof optimization in our network, and there is functionality in libIndy that's allowed to send and works with plugged request and response. But before this task, before this optimization state proof for custom, all requests was following the full model. Then each request will send it to each node and getting consensus for it. But now we just merge a new functionality, and now each plugin will provide building a custom request, also can provide some parser for node data reply and checking state proof. The main idea here to perform all complex math and crypto works on libIndy side, and plugin will just parse node reply and provide fixed structure for state proof verification. I would like to point the two main things. The first one is design document. You can find it in Indy SDK design documentation, docs, design, state proof plugin parsing. There is some background here, and goals API, and major things here is parsed data structure. In this section, detailed description provided for exact data and elements which plugins should return to libIndy to achieve state proof optimization for custom request. Also, I'd like to share some tests. Let's run test for integration. It's passed, and one more complex test about full integration during API level. It's also passed. That's all. Thank you.
Yes, thank you for that. Nikita, can you share your screen? Are you still on mute, Nikita?
Do you see the picture?
And we're seeing your screen and we're now hearing you, but it's pretty quiet. Much better.
Oh, okay. As you know, sometimes we need to collect data about pool condition from all nodes. It requires many communications with stewards. It requires very much time. So we add new command in the CLI, which help us to collect data easily without direct communication with all stewards. There's limited access to this data. You must be at least steward or trustee to do this ping. Now, I'm not a steward. I change my DID to steward. Yeah, now I'm steward, and now we have data from each node in the pool. The command sent requests to each node individually, and all replies aggregated in output. I can get this from single node. And we have valid JSON for future processing. That's all. Any questions?
Yeah, maybe in the future it can be more useful if you will save the output to some file. Yeah, but actually I believe it's possible with batch mode of CLI already. Yeah.
So this looks awesome. What info, what data are we capturing from each node? I see it, but we went through it pretty quickly. Are the stewards okay with us taking this information from their nodes? Is this anything that would cause a steward troubles?
We have hardware, software, for example, installed dep packages, and some information about a ledger, for example, current catch-up statuses, pool ledger size, all ledger size, not only pool, some performance metrics, and yeah, there is all data you can find if you run a validator-info script directly in the node.
So maybe the only quite more or less sensitive data here is hardware. So yeah, we can double check. I believe when Trev and Mike will discuss it with stewards, they can get some feedback about this.
Okay. Okay, that's my only concern. This is fabulous. To be able to just go get this kind of info at once on every node is great. We just have to make sure the stewards are okay with that.
Yeah, there's an open ticket for us to, I actually don't know if it's open, but there was a ticket where we were working with Mike and Trev to decide on the right way to handle the permissions for this information. Currently you have to be a steward to be able to pull the information, but the concern is that it's run automatically from a script. And
right.
But you already have local access to run automatically from a script, so you already have the hardware info anyway.
For your node, right? But not for everybody else's.
Yeah, and so the idea is to require additional permissions to be able to do it remote versus...
Okay. I think this is very cool. Thank you.
Yeah, anyway, execution of this command requires to be at least steward.
Right. It's just that one steward is looking in on all other stewards, and that's my only concern.
Yeah.
And so we did have a security conversation about that. If you look in the sprint history, you'll be able to find the issue that has that.
Yeah. Okay.
All
Thank you.
If you have that issue number handy, Nikita.
I can find it. I know how to do that.
Yeah. But for anybody else who's interested, because I'm sure other people have the same question, I appreciate you asking. So thank you very much, Nikita. I do want to thank you for your participation. Nikita has been really important on the SDK team, working, helping with all of our quality questions. He's moving teams for the next while. He'll be working with the token team, and working on other projects. So we're excited for him to be doing that, and but we appreciate his participation here. It does mean that
yeah, talking about different Nikita who is moving to SDK or to tokens team.
I apologize for confusing.
All our Nikitas are doing great job. So
all of our Nikitas are doing a good job, but we do have the SDK team is going to drop by one member for the next couple sprints. So we do expect a slight hit to velocity for that, but it's going to be important to help other teams to meet their commitments to our customers. Okay, thanks for correcting me, Alex. Next demo is, I lost my sheet. Sergey.
Yeah. Okay. Sorry, it's another screen. Yeah. Can you hear me? And can you see my screen? Yeah. I'm going to show you a short demo that demonstrates usage of separate links. I think it would be better to start with current binding configuration that that is specified in Indian file, and then I will run a migration script which adds node and client listener IPs to Indian file, and then I will change these IPs and check that Indy Node binds its listeners correctly. First of all, during the next upgrade to the next release, a migration script that adds node-declared IP listeners will be run. And let me emulate it. Yeah, and check that node IP and client IPs are added. By default, these IPs are set to all zeros. This is done in this way because we don't want to break network. If we set, for example, public node IP, then this public IP may be on different machine if stewards use external firewall. So that initially we set all zeros for now. And then let's start Indy Node and check that both listeners are bound to all zeros. Then, for example, as a steward, according to my hardware configuration, in addition to local interface, I have two interfaces, ETH0 and ETH1, with different IPs. And for example, I want to set 10.0.0.2 for node listener and 192.168.02 for client listener. I do something like that. And the second one. Yeah, And to apply these changes, I need to restart Indy Node. Stop and start the game, and then let's check bind information, and we can see that Indy Node listener, node listener is bound to 10.0.0.2, and we can see this pair in nets.output, and client listener are bound to second IP. So we can see that the configuration is current. For example, again, as a steward, I want to change this configuration. I need to stop, and for example, swap these two IPs. I need to stop Indy Node, then open Indy again, and I'm going to swap these IP addresses. 10.0.0.2. Start Indy Node again, and check output of netstat. And we can see that not implied listeners are bound for specified IP addresses. Thank you very much. Any questions?
That's excellent. I want to emphasize this addresses a major concern we had where clients that were connecting to the external port could potentially disrupt consensus if the consensus port on Indy Node was listening for those connections as well. And so this does isolate those. Also in this sprint, we did work to make sure that the connection buffer is 3 times larger for that consensus port than it is for the client connections. And so if somebody tries to flood the client connection port, it's going to stop dropping connections before the consensus port gets interrupted, long before. And so that should help with the robustness of the network.
And yes, for now we have two different parameters related to client queue and node queue. But I can't show you using demo because all dropping of packets from queues are hidden from application. It's inner job of 0MQ.
Yeah.
But if you want, I can show you these two parameters, but I think it's not very informative.
Yeah, I was just making sure people knew. That's documented. You can find the issue. If you're interested in changing it, though, we're happy with where things are at. So thank you very much, Sergey. We need to move to the last demo. So Renata, you can share your screen.
Hi.
Excellent.
Can you see my screen?
Yep, and you sound, your mic's high. Oh.
I have other microphone, not this.
Oh, okay. Sometimes I talk with my mic up. Go ahead.
I want to talk about migration to DigestK. And some time ago, we found a problem that caused many bugs in the sprints in many structures. The pair identifier and request ID were used in a UniK, but it's not true because both fields come to us from the client and we don't validate it. Let's look through the two collisions that we have. Now on the client sent a request, it's okay. And a response, we processed the response and sent to the client. It's and recorded in the special structure SIGNODB. Now we send a new request with the new data, but we use the old identifier and request ID. Despite the obvious difference in the request, we have the same primary key. As a result, the client receives an incorrect response, and the request will not be executed. Sorry. We fixed this problem with the digest. We change K and sec node B to a digest that includes not only identifier and request ID, and it includes operation. We change it K, and now we can, our client can receive correct results, request, response, and it will be correctly saved, stored in the SecNodeDB. Now let's look at the even more dangerous case. The client sends a request with different operation data, but the same identifier and request ID, which leads to collisions. No one of the requests will be recorded, and the consensus will be lost. We fixed it by replacing the identifier and request ID with the digest. As a result, the following structures are migrated into the digest. Now, these structures was migrated to digest K. Its monitoring lists and node lists such as requests and information about senders, and we change format of transactions. Now all tests are correctly passed, and I think we will merge it into the master in the near time. And that's all. I think I can show you a beautiful case that you passed correctly. Thank you. Have any questions?
That was a great explanation. We have time for one question if anybody has questions about any of the demos today. Well, somebody thinks of a question, just so you're aware. So the next sprint, the SDK team is going to be focused on releasing the 1.5 release of the SDK that will include the improved wallet, the payment stuff, everything that was demoed today. So we're excited about that. The Node team is going to be also focused on a release, the 1.4 release, which is first stable release on, well, we had a hotfix recently, but it contains all the goodness that we've built over the team has built over the last 4 months. So excited for that. Those two releases are the focus of the next sprint. In addition, the Node team is going to start working on additional stability and starting to look at how to improve the logging and monitoring for the future. So any questions? Last question?
No questions, but thank you, everybody. This is awesome stuff.
It is. Thanks, team.
Excellent. Nathan, you're our other guest of honor. Any questions?
It's good to see demos of all this stuff up and going. So thank you for the good work, and it's wonderful to see these demos. I hope that others in the community get a chance to see them, and I look forward to hearing what they say about it.
Excellent. Starting this week, we're going to be posting these to the Hyperledger YouTube channel as a playlist. So people will be able to have access there. And so if you see this video on YouTube in 2 weeks, we will have our next video posted. So today is Thursday, June 7th of 2018. Next one we'll post on the 21st.
Excellent.
Okay, thank you. Have a good day, everybody.
Thank you.
Thank you. Bye.
Bye.